Hello everyone, my name is Alix Goguey. I'm a postdoctoral fellow working with Carl Gottwin at the University of Saskatchewan, and today I'm going to present you a project that started during my PhD and was led by Damien Masson, a master's student at the University of Lille, supervised by Sylvain, Malacria, and Géry, Casiez. So one of the main topics that drove research on touch modality for the past decades is the increase of the input vocabulary. Compared to desktop computers, touch devices embed significantly less power of expressivity, with every action undertook by a user has to come from a 2D location similar to the use of a mouse. As a result, touch versions of software tend to offer a subset of all the possibilities provided by their desktop counterparts. For example, on Photoshop, Photoshop on desktop offers more than 600 commands, whereas on smartphone, only a few dozens are available. So to augment the input space, researchers added new dimensions. By leveraging new information such as pressure, or orientation of the finger, or body parts. And also identifying which fingers cause which touch, more commonly known as finger identification. Finger identification has seen a rising interest and given the increased input vocabulary it provides. By executing similar physical actions, but with different fingers, the user can input different commands to the system. As a simple example, we could map different commands to different fingers. For instance, in a vectorial drawing application, drawing a rectangle using the index finger and drawing ellipses with the little finger. Identifying finger on a touch surface is not a trivial problem to tackle. A lot of prototypes have been developed over the years, but the current solutions are either needs to all fingers to be in contact with the screen, need a clean hand shape, are expensive, cumbersome, not real-time, or not easy to reproduce. So no technology efficiently supports finger identification yet. And more importantly, the reliability of the prototypes is seldom reported. We only found 5 works that report their recognition rates. However, their prototypes recognize a subset of all the possible chords. So, although we believe that the future generations of multi-touch devices will embed a non-invasive, mature, and reliable finger identification technology, using, for example, capacitive sensing or 3D ultrasound biometric sensors, researchers need a robust environment to explore the use of this information to propose useful applications today. So we therefore propose WhichFingers, a reliable, open-source, low-cost, easily reproducible, multimodal device enabling real-time finger identifications. It uses piezo-based vibration sensor, does not require calibration, and works not only on touch surface, but also on keyboards and support cross-device uses. The WhichFinger prototypes consist of 5 millisense 100 vibration sensors attached to each finger using elastic rings. Our underlying assumption is that the finger that contacts any surface produces a higher response on its sensors compared to the other fingers, and thus can be identified. The 5 sensors are plugged into a microcontroller through a custom design shield. We developed a device prototype using Arduino boards that reads the voltage of each sensor and sends the raw values to a host computer at 1,000 Hertz using raw HID over USB. In total, it costs less than $35. The device is coupled with a low interaction monitor that detects interaction events such as touch events or key press. To identify which finger has been used, we use a simple algorithm that examines which vibration sensor created the highest voltage right before the event occurred. The value of the vibration sensors are sampled at 1,000 Hertz, which is usually much higher than the frequency of detecting low-level events, which is around 100 Hertz. The algorithm retrieves the max value within an empirically defined time window of 30 milliseconds, and this time window can be customized in function of the hardware used. The device is inherently real-time since finger identification is available as soon as a software event is detected. If a second contact occurs with its time window overlapping the first one, the two time windows are merged into a unique one, and the algorithm retrieves the two max values. Those contacts, which are less than 30 milliseconds apart, are considered simultaneous by the host application, and thus fingers needs to be disambiguated using a heuristic, like the XY position on a touchscreen or the key location on a keyboard. To be noted, finger identification is available at most at the second touch frame. We first developed a wired version using an Arduino Leonardo board, and continued the development and issued other version using an Arduino MKR1000, which works both in a wired configuration or over Wi-Fi. The wired version will be available for demonstration tonight at the demo reception. And in the following, I will present the results were obtained using the Arduino Leonardo board. So WhichFingers is able to identify every combination of finger from single contact to 5 finger chords. In both our experiments, we tested single fingers configuration and 2 finger chords, those configurations being the most used. We video recorded all the trials and manually labeled each contact point of the gesture with the finger used by the participants. So we first conducted a control experiment to evaluate the robustness of WhichFingers. We asked 15 participants to contact and perform slides on the touchpad, as well as typing keys on 2 different keyboards with 2 different travel distances. For all conditions, we imposed which combination of dominant hand fingers to use, either 1 finger or 2 finger chords. For the touchpad part, participants had to perform 2 different types of operations. A tap, which corresponds to tapping the touchpad, and a slide, which corresponds to performing a quick unidirectional gesture in any direction. There was no requirement for the direction of the movement, so that we have no prior knowledge when doing the recognition. And participants could touch the touchpad at any location. The 5 individual fingers, as well as the 10 possible 2-finger chords, were tested. For the keyboard part of the experiment, participants had to perform 2 different types of operations on the keyboard. A type, which corresponds to typing a key, starting with the finger not in contact with the keyboard, and a push, which corresponds to pressing a key with the finger first position on it. The participants could press on any key. In this one, the 5 individual fingers were tested. The overall recognition rate for the touchpad was more than 96%, more than 99% for single fingers, and more than 94% for 2-finger chords. After analyzing the video of the trials, we found that the lower recognition rate for chords is mainly due to 2 chords, the middle finger little chord and the thumb little chord. They correspond to hand postures that are difficult to articulate, and thus we hypothesize that users tend to tense their hand in order to hold those difficult postures, which increases the sensitivity of all the vibration sensors. The overall recognition rate for the keyboards was more than 98%, more than 99% for the low travel distance keys, and more than 97% for high travel distance keys. We then tested, we then conducted a second experiment to evaluate the robustness of WhichFingers in a non-constrained scenario using tasks representative of daily activities on the desktop computer. We asked 12 participants to complete 4 tasks that make use of a trackpad and our low travel distance keyboard. We tested a pointing task where participants had to click on circular targets, a scrolling task where participants had to use a 2-finger scroll to find a target item on a list, a docking task where participants use 2-finger gesture to translate, scale, and rotate a geometric form, and a text entry and formatting task using the keyboard only, where participants had to reproduce a formatted text. In this one, participants were prompted an Apple Pages software window with the partial text alongside the target text to achieve in a disabled window. The keyboard shortcuts were modified so that all were issued with the left hand, which was the hand equipped with the device, and they were the shortcuts were reminded at the bottom of the disabled window. The overall recognition rate for the touchpad was more than 94%, more than 98% for single fingers, and around 92% for 2-finger chords. For the keyboard, the overall recognition rate was more than 99%, and more than 99% for the single fingers, and about 98% for 2-finger chords. So overall, the results of our 2 experiments first highlight that WhichFingers is an accurate, low latency solution to identify fingers in various conditions. And more generally, these results indicate that fingers entered in a sequence, so one after another, can be detected in a robust way. However, we identify different causes of error that can be addressed in future work. In some situations, the wires collided with each other, which produced a signal on neighboring sensor that is then wrongly interpreted by our monitor. So our prototype could be improved by using less rigid wire. We also designed our hardware and software to make it easy to replicate, and thus intentionally use a simple signal processing algorithm that can be used as the backbone on which heuristics tailored for particular interaction context can be added. For instance, in an interaction context that involves scrolling gesture, finger could be disambiguating using the X position of the contacts. The leftmost contact would be associated with the leftmost finger, and the second contact would be associated with the remaining finger. For rotational gesture, the Y position could be used the Y position could be used. The downmost contact would be associated with the leftmost finger if we are using the right hand, or the rightmost finger if we are using the left hand. And finally, even though we when informally using our Wi-Fi prototype, we found similar performances, a rigorous testing of the prototype still needs to be carried out. And so I'll let you with some example that we implemented. So our device can be used in system-wide, running a background application that can overwrite the OS routines. For example, we overrode the OS pointing routine to implement a switch between relative and absolute pointing. We also implemented the scrolling equivalent, in which an index finger scrolling gesture triggers relative scroll of a document, and the middle ring scrolling gesture triggers an absolute scroll of the document. And in our last example, we overrode the Windows management system, in which an application window occupies the left, right part, or the entire screen, depending on which chord is used while clicking on the menu bar. So to summarize, we presented WhichFingers, a reliable, open-source, low-cost, easily reproducible multimodal device that enables real-time finger identification. And all the material needed to replicate the device, as well as the paper and the video, can be found at this address. Thank you for your attention.
All right, thank you. We have time for